Hello to all. In this video, we will solve some problems based on topic distance, speed and acceleration. In this question, a bus is traveling along a road. It travels a distance of 400 meters in a time of 25 seconds. Write the equation used to calculate the average speed of the bus. So we know the average speed is equal to total distance traveled divided by total time taken. The unit of average speed meter per second, and explain how you can tell that the bus has no acceleration if the speed time graph is given. So we can say that speed is constant, speed is not changing with time, speed is constant, and acceleration is rate of change of speed, so acceleration is constant here. Copy the diagram and shed the area that represent the distance traveled by the bus. So we have shaded the area. We know that the area under speed time graph represent the distance traveled. So this is given here. The graph represents the motion of a bus. It is in two sections, A and B. What can you say about the motion of the bus during these two sections? So we know that this is a distance time graph, and the slope of distance time graph tells us the object speed. So in both sections, bus is moving with steady speed, and the graph becomes more steeper in section B. The steeper the graph, the faster the bus is moving. So the bus speed is more in section B. This figure shows the graph of a speed time graph of a train as it travels from one station to the next. We have to calculate the distance between these two stations. So again we know that the area under speed time graph represents the distance traveled by the object. We will calculate the area under this graph, and here the solution is given. You can pause and please check every step written here. The area of this triangle is 1 by 2 multiplied by base multiplied by height. Base is 10, height is 18. The area of this rectangle, side of these two multiplication of these two sides, 18 multiplied by 180, and again the area of this triangle is 1 by 2, base is 20 and height is 18. So the answer is 2.43 kilometer. The acceleration of the train in the first 10 seconds we have to count. The acceleration is the slope of speed time graph. So for the 10 second the graph is showing by this straight line sloping up. It represents a steady speed, and acceleration will be gradient. So gradient we have calculated here. It is 1.8 meter per second square. The mass of the train is given. Calculate the resultant force. Force is mass multiplied by acceleration. So the answer is 1.98 into 10 to the power 5 Newton. This is a distance time graph by a car on a roller coaster ride, and we have to give information about each point. So the car is stationary, point 1 and point 5, point 1 and point 5, zero gradient, distance is not changing with time. The car is traveling its fastest, point 3, graph is steepest. The car is speeding up, point 2, the graph is sloping up. The car is slowing down, point 4, graph is less steep. And the car starts on its return journey, point 6, negative gradient shows distance is decreasing. I suggest you to watch a video where we have discussed in detail about the topic, the distance time graph, and what information we get from distance time graph, so it will be helpful for you. In a laboratory, an experiment is carried out to measure the acceleration of a trolley on a horizontal table when pulled by a horizontal force. The measurements are repeated for a series of different forces with the results shown in a table below. Plot these points and draw the best straight line for your point. So here the plot is given, and the best straight fit of these data points is represented by this black solid line. The graph shows the below a certain force there is no acceleration. What is the value of this force below which there is no acceleration? So here the value of this force is 1.6 Newton, below which there is no acceleration. A force smaller than that in calculated in part 1 is applied to a stationary trolley. Suggest what happens to a trolley if anything. So the trolley remains stationary as any force smaller than observed in part 1 will not be able to produce any acceleration. Show that the gradient of your graph is about 5.7. Here we have calculated the gradient. You can see the calculation. The coordinates here are 14 and on y-axis it is 4. On x-axis it is 2.25 and here it is 0.5. So change of coordinate on y-axis over change of coordinate on x-axis is the gradient, which is 5.7 in this case. Use your gradient from this section to find the mass of the trolley. Here force is plotted on y-axis and acceleration on x-axis, and the gradient of force acceleration graph gives a mass. So mass is here 5.7 kilogram. A person is standing on the top of a cliff throwing his stones into the sea below. The person throws a stone horizontally. Draw a line to show the path which the stone might take. So we have drawn the path here. On the line you have drawn at a point halfway to the sea, mark the stone. The stone is marked here and the direction of force on the stone. The direction of force is a downward. It's a gravitational force acting on a stone. Later the person drops a small stone and a large stone vertically from the edge of the cliff. Comment on the times taken for the two stones to hit the water. So case 1, if air resistance drag force is negligible, then two stones will reach at the same time, as motion of both stones is governed by only gravitational force. Case 2, if air resistance drag force is non-negligible, then air resistance will be high for lighter objects and will be low for heavier objects. So heavier stone will hit the ground first, as it will experience very less air resistance. Here the another part of this question, 800 meters from the point where the person is standing, a navy ship is having target practice. The person finds that if a stone is dropped vertically at the same time as the spurt of smoke from the ship's gun is seen, the stone hits the water at the same time as the sound from the gun is heard. Sound travels at 320 meters per second in that region. Calculate the velocity with which the stone hits the water. So time covered by the stone to hit the water is equal to distance divided by speed. It is 2.5 seconds. And velocity of a stone is equal to acceleration g multiplied by time. So it is 23.8 meters per second. We can take 10, the approximate value of g here also. In which sections was it acceleration 0? Section B and section D, as this is a speed time graph. Speed is constant here and acceleration is rate of change of speed. So in section B and D, acceleration is 0. In which section was it acceleration constant? In section A and section E. A and E represent steady speed. Speed is increasing, speed is decreasing. So A represent acceleration, E represent deceleration. But this is constant. What can you say about its acceleration in the other section? Section C shows non-uniform motion, so acceleration is not constant in section C. It is non-uniform acceleration. State the value of the distance represented by the shaded area. So distance is equal to 10 plus 5 plus 10, as distance is the length of total entire path covered by object. So it is 25 kilometer. State what the car was doing during the interval, OP. So OP is speeding up. It represents steady speed. So car is accelerating, but acceleration is uniform. Uniform acceleration is here. PQ constant speed. It means zero acceleration. And QR showing down, slowing down. The speed is going down. It is decreasing, but it is a steady speed. So it is decelerating. In the average speed during the journey, the same, less than or more. So average speed will be less than the maximum speed. This figure shows the speed time graph for a car traveling along a straight road. The graph shows how the speed of a car changes as the car passes through a small town. So this is the point where a car enters town here and car leaves town here. Describe what happens to the speed of the car between A and B. Steady speed, decelerating. Speed is decreasing here. Between B and C, constant speed, zero acceleration. Between C and D, steady speed, accelerating. Sloping up, so speed is increasing at a constant rate. Calculate the distance between the start of the town and the end of the town. Means calculate the distance traveled between B and C. So we can calculate area under this graph. and area will be the multiplication of these two sides. It represents a rectangle. So it is 42 minus 18, it is 24 second, or is this length is of 13. So distance will be 24 multiplied by 13, or you can calculate by this formula also. Distance is equal to time multiplied by speed. So time is 42 minus 18 and speed is here 13. Calculate the acceleration of the car between C and D. So you have to calculate the gradient here, as gradient C coordinate is 42 and E coordinate is 54 on time axis. So CE is equal to 54 minus 42. For DE, the coordinate of D is here 31 and E is here 13. So DE coordinate is 31 minus 13. And gradient will be DE divided by CE. It is 1.5 meter per second square. State how the graph shows that deceleration of the car has the same numerical value as its acceleration. So we can calculate gradient here. This represents acceleration and this represents deceleration. So gradient AF divided by FB is equal to the coordinate of A 25 on speed axis, coordinate of F is 13. So AF is 13 minus 25, and on time axis we have the coordinate 18 and 10. 18 is the coordinate of B and F coordinate represent 10 on time axis. So FB is 18 minus 10. So we can calculate it is minus 1.5 meter per second square. An object moves at a constant speed for some time, then begins to accelerate. Which distance time graph shows this motion? Here option C is right, as initially the object moves as a constant with constant speed because the gradient, the slope is constant here, and then it begins to accelerate. Here initially the object is moving with constant speed, but then there is no acceleration. Here it is non-uniform motion, object doesn't have constant speed. Here distance doesn't change with time, so speed is 0. Two distance time graphs and two speed time graphs are shown. Which graph represents an object that is at rest? Here option B is right. Here distance doesn't change with time, so object is at rest. A car moves with constant speed and then constant acceleration. Which graph is the speed time graph for the car? Option C is right. Here car speed is constant, as speed doesn't change with time. This part shows steady speed, so acceleration is constant. In this question, a car is moving downhill along a road at a constant speed. Option C, speed doesn't change with time, it is constant here. Speed time graph shows the motion of a car. Which row describes the motion? So from P to Q, initially there is a steady speed. It is accelerating, but this is a uniform acceleration. Q to R, speed is constant, acceleration is 0, and speed is constant definitely. Accelerating between P and Q and moving at constant speed between Q and R. The diagram shows the distance time graph of an object. Which statement describes the object? As it is moving at a constant speed, the slope, the gradient of the graph is constant, and the slope of distance time graph tells us object speed, so it is moving at constant speed. The graph represents the motion of a car. What is the distance traveled by the car while it is moving at a constant speed? So this horizontal line from 15 seconds to 25 seconds show a constant speed. Here speed is constant. Speed doesn't change with time. So we have to calculate the area under speed time graph, which represents the distance traveled by any object. Here area of one rectangle will be 5 multiplied by 10, it is 50, and area of two rectangle is 100. So answer is 100 meter. Option A is right. An aeroplane flies from town X to Z, stopping for 1 hour at town Y to pick up more passengers. The distances between the towns are shown in the diagram. We have to calculate the average speed. So total Distance covered is 500 km, 300 plus 200, and total time taken is 3 hours minus 1 hour because 2 hours. Now the average speed is option C, 500 divided by 2. A tennis player hits a ball hard and 0.40 second later hears the echo from a ball. The speed of sound in air is 330 meter per second. How far away is the player from the distance? We have to calculate the distance. Now the sound travels the distance d twice, first from the player to the ball and then next back to the player. So 2d is equal to speed multiplied by time. 2d is equal to 300, speed is given, time is given, so d is equal to 66 meter.